Okay, in this video I want to talk more about vertical and horizontal stretching and reflecting, and I'm going to definitely talk about case 3 and case 4, which deals with horizontal stretches or compressions, and then 5 or 6 deals with reflections. Maybe we'll get to that one, we'll see. Again, the basic idea in 3 with these horizontal compressions or stretches, if you multiply by a number bigger than 1 on the inside, it's actually going to squish your graph together. If you multiply by a number between 0 and 1, it's going to actually pull it apart. Okay, so let's look at at least 2 examples. So again, here's my original graph here at the top, my blue graph. This is the one I'm going to tweak to come up with a new one. So it's this little sawtooth function, -4, 0, -3, -2, -2, 0, -1, 2, then 0, 0, and then it's this little step function. Okay, so what I'm going to graph now is the function f of 2x. And what this again does, since I'm multiplying the x's by 2, it's actually going to compress the graph. It's going to basically compress it by a factor of 2. So instead of going out from 0 to -4 and 0 to 4, it's now going to go from 0 to -2 and 0 to 2. I think this is the one that always confuses people as well. You know, because hey, you're multiplying by 2, that should make things bigger, but you can't really think about it like that. Or I guess if you do so, it's not correct. Think about it this way. You know, if I plug -1 in, if I let x equal -1, what would I get on the inside? I would get a value of -2. But according to the original graph, it says if you plug -2 in, you should get 0 out. So if I plug -1 in, I'm going to get -2 on the inside, which should give me an output of 0. Okay, and that's the basic idea. You're going to kind of cut the x-coordinates in half. So originally at -2, there was an x-coordinate of 0. If I cut that x-coordinate in half, it now becomes -1. Keep the same y-coordinate. At -4, the original x-coordinate is -4. If you cut that in half, you'll get -2. Okay, originally at -1, it was up here at a y value of 2. If you cut -1 in half, you're at -1/2, and then I'm up here at 2. Likewise, at -3/2, I'm going to be down here at -2. Okay, so it still has the same height, but everything has gotten squished together by a factor of 2. Okay, and then that's going to be the same thing that happens on the right-hand side. Instead of extending out a distance of 0 to 2, it's only going to go out from 0 to 1. And then instead of going out from 2 to 4, it's going to go out from now 1 to 2. Okay, again, imagine chopping the interval 0 to 2 in half. You get 0 to 1. Imagine chopping the interval 2 to 4 in half. You would get the interval 1 to 2. Okay, so again, notice the heights are the same, but it should look definitely a little more squished together. Okay, so let's do another one of these. Now what I'm going to do is, again, very much a similar thing. I'm going to multiply now the inside by 1/2. And now if you multiply by a 1/2, instead of compressing it by a factor of 2, you actually stretch it by a factor of 2. So I can't kind of keep the scale correct on this graph because I've got -4 to 4. So now the idea is, instead of getting squished together, you're going to pull it out by a factor of 2. So that means I'm going to go, instead of from out to -4, I'm going to go all the way out here to -8. And instead of +4, I'm going to go all the way out here to +8. Okay, and now basically you do the same thing. Originally at -2, that's where I got a 0. If you multiply that x-coordinate by 2, because we're stretching it by a factor of 2, you're going to go out to -4. Okay, and at -1 you originally had a y-coordinate of 2. Well, now if you multiply that x-coordinate by 2, you're going to be at -2. And then we'll be up here at a height of 2. Likewise, at -6, we're going to be down here at a height of -2. Again, if you multiply that original x coordinate by 2, you're going to keep that same y value, but the x value turns into -6, and the x value stays the same. So again, connect the dots. Obviously, again, I'm not a great artist, so forgive my artistry. Again, it doesn't really look stretched out because, just the proportions of my graph. But, if you had a bigger piece of paper, I think you would definitely see this thing looking more elongated. So try that for yourself. And then we'll go from, we'll go all the way out to 4 this time. So instead of being this little horizontal line at -1 from 0 to 2, again, now I double that, so it's going to be looking like that all the way out to 4. And then I jump down to -2 at 4, and that extends all the way out to the value of 8. Okay, so this would be the graph, again, of f1/2 of x. And I'm definitely going to put all of this stuff together in some more concrete examples. Again, just trying to give you a general idea of what's going on. Let's see, I don't know if I can do the other two real quick. We'll save the other two for one other video. So this again deals with horizontal stretches or compressions. Next, I'll basically deal with flips about the x-axis and flips about the y-axis. So look for another video, and then again, stay tuned. I'll do some more general ones where I do all the compressions and stretching and rotating and shifting and all of that stuff combined.